I forgot to start the recording. It's okay. So, all right. So we are discussing that what free fall motion is. So the motion that that is taking place under the gravitational field, and we have already had a understanding of gravitational field. What gravitational field is, right? So the field that gravitational field is due to the the field the field due to the heavy masses, right? Okay, so that another heavy masses can experience a force of attraction, force of gravity. Okay, like sun has its own gravitational field around its own orbit, and it attracts other stars and different planets, right? And different planets have their own gravitational field. So when we talk about the object is falling, or is falling freely, that means that it is acted by a constant force, right? And that force is acting every movement, right? And it is speeding up. So how can we say that body is speeding up? For example, if you throw one object, so do you think it will speed up, or will it have the same speed? What do you think?
When it's falling, it will have constant speed.
Okay, constant speed. All
No,
right. So
sorry, it'll speed up. Sorry, it'll speed up.
right. Yeah, a different speed. Okay. So when we throw the object, so initially the object is at initially when it is not it is not released, so it has initial velocity 0, right? But when it covers some distance, so its speed increases every second, right? And since the attraction from the earth, right, is 9.81. So every time the speed increases by 9.81 meter per second in every second, right? Are you getting my point, what I'm saying? 9.81 meter per second in every second. Clear? Are you getting my point? The
Yeah.
speed is getting increased every second by 9.81 meter per second, right? Okay, so initially this is the case. This is the case. Then when it is not released, so it has initial speed 0. Okay, initial speed is 0. Now it is speeding up when it is released from here, and it goes down, right? So due to gravitational or gravitational field, or strength of gravity, due to strength of gravity, the the body is speeding up, right? Speeding up. Clear? Every second it its speed its speed increases by 9.81 meter per second. Clear? So this is a constant value. So what do you think when the speed is being increased? What will happen? Will air particles strike on it? Yes?
Yeah.
Yeah. So more air particles will strike on it, or less number of air particles will strike on it? If it is getting, if its speed is getting increased, what do you think? More air particles are going to strike on the
More.
object? Yeah, more air resistance will be experienced by the object. Clear? Clear? So that means we cannot neglect the force, right? So ideally, we can say that if there is no air resistance, right? So the object, whatever the size, whatever the you know, the size, right? The object has, it will have, all object will move with the same speed. Okay, clear? But when we talk about the air resistance, when we talk about the air particles, right? So different size of the objects will have different speeds. Okay. So when the object is speeding up, every moment when the object is speeding up, right, coming down towards the earth, right? So the air particles, more air particles are going to strike on it. Okay. And what do you think? Making it slow down or making does it not have any impact on its motion?
The more air particles, it tries to get slowed down.
Yes. So in reality, what we can say here, in reality, air resistance affects the motion of the falling objects, right? Slowing them down and causing them to eventually reach a constant speed. Yes. So the time comes, the speed becomes constant. Clear? The speed becomes constant. Okay. Are you getting my point? Is this point clear to you or not?
Kind of.
Okay, fine. Let me explain it again. Initially, the body is speeding up, right? Okay. Initially, whatever the speed the body has, right? Let's say it has 2 meters per second, right? Now, after 1 second, it has increased by let's say 11.81 meter per second, right? And after 1 second, it is increased by 8.1 plus whatever the speed is going to be around 20, right? Let's say approximately 20 meter per second, okay? Right? So what are you observing here? Every moment in every second, there's a difference of the speed. There's a difference of the speed, yes? There's a difference of the speed.
Yeah.
Yeah. So what is the difference in each moment, in each every second? That is
It's
around
increased.
9.81, right? That is
Yeah.
around 9.81. Okay. Now, when you speed up your body, when you speed up your car, when the body is moving with greater speed, so more number of air particles will strike on it. Okay. So what will happen? The body, the body is going to slow down. The body is going to get slowed down, right? Okay. And then there is the time comes where the downward force and the upward force, both forces, both forces are going to become balanced, right? Okay. And we have studied two things. When balanced forces are acting, when balanced forces are acting, so two things are possible, right? Number one, either object moves with constant speed. Okay. Is this point do you remember? Balance forces, when the forces are balanced, the object has to move with a constant speed, or there's
Yeah.
another possibility, the object is going to be at rest. Okay. Clear? So over here, we have a case that our object is moving. So it will continue its motion, but will have to move with a constant speed. Now, is this clear to you?
Yeah.
Yeah. So initially, the forces are not balanced. Initially, forces are not balanced, but when the forces become balanced, the object is going to move with the same constant speed. That constant speed is called terminal velocity. Is this making sense? Okay.
Yes.
The
Yeah.
moment where forces become balanced, that moment, that velocity, okay, at that point, at that moment, the velocity becomes constant, and that constant velocity is considered as terminal velocity. Okay, right? So what we can conclude here, air resistance, you can see here, air resistance from here. Air resistance increases as the object's speed increases, right? I have discussed this point. Okay. Eventually reaching a point where the air resistance equals to the object's weight. So weight is downward and air resistance is acting upward. Both are becoming balanced. Clear? Both are becoming balanced. Clear? So since the both forces are balanced, what is going to happen? The net force of the object is zero. Okay. Are you getting this point or not? Please.
What's the net for?
Net force. Oh, resultant force, beta. You remember we studied. Okay, let me show you. Let me recall that
Oh yeah,
concept.
result. Yeah, I didn't.
Yeah,
Yeah,
you
I did not
remember?
know that.
Okay,
Net
okay,
for.
fine. Okay, so I think in one of the lessons we discussed the to find out the net force. Yeah, resultant force, net force. Okay. All right, all right. So let's go back to that lesson. All right. So the net force, that is the resultant force on the object is zero and it falls at a constant velocity. So yes, it is fulfilling that concept that when the forces are balanced, the object will move with the same speed. Is this clear now? Which is called a constant terminal velocity. Clear? Got it? Now, any confusion?
No.
Okay. Let me show you one thing here. Um, okay, what will happen if different objects are released from the same height, but um, the size of the object is different? Okay, so who will reach the terminal velocity first? The lighter one, or sorry, the the object which has the greater surface area, or the object which has the lesser surface area?
The one with the lesser surface area.
Greater surface area? Yes. The object
No, lesser.
less surface area. Okay, so the object having the less surface area will reach to the terminal velocity first. How?
No, I thought it's okay. I know. The greater surface area.
Greater surface area. How can you say that greater surface area, beta?
Uh, cause
Think about it. Just take 30 seconds. Okay.
wait, can you repeat the question?
Okay. So which object will reach terminal velocity sooner? Okay. The one which has the greater surface area, or the one which has a lesser surface area? Yes.
Uh, I think greater.
Okay. So the greater surface area, see, think about the parachute, right? So how parachutist balance himself herself? Yes. Initially, does the parachutist open the parachute?
Wait, what?
Have you heard about the parachutist? How,
Yeah, yeah.
yeah,
You
how
said
do they balance? How do they
how the
balance?
yeah. As soon as they're like near the surface, when they put out the parachute, the parachute has a great surface area,
Yes. Okay.
so it tries to catch more air, so air resistance is higher.
Yeah. So when it gets opened, okay, so it's the surface area becomes greater. Okay, and this is how the um, the parachutist balance himself. Okay, and reaches to the terminal velocity. Okay, let me show you one thing here. It will be easy for you to understand. Now see this one. See this one. Yeah, can you see now? Yes, thumbs up. Can you see?
Yeah.
Okay, so he's going to accelerate downward, right? So only the weight is acting. Initially, weight is acting on it, right? So only weight is acting, clear? And when smaller resultant force, that means acceleration decreases. Okay, so there's another force that starts acting on it, that is air resistance, and the weight is still there. Okay, you can see the size of the arrows, right? Both sides of the arrows are different. Okay,
Yeah.
now finally the size of the arrow of air resistance increases and weight.
All the same.
See, both are balanced, right? Are same. So this is how air resistance and weight here are balanced, and the body does not have any resultant force. Okay. So this is the time where the body reaches to the terminal velocity, right? Okay. Now, if the person wants to slow down, so what he's going to do?
Parachute to
Yeah,
higher
he
resistance.
has opened it. Okay. Now this is how it will have more surface area, right? Okay. So this is how it slows down. Clear? Now, are you clear about the terminal velocity and everything? Got it?
Yeah, yeah. Yes.
Okay. So then, new slower terminal velocity. Why? Because if um, smaller resultant force is acting. Why? Because this time air resistance is greater than the weight. Clear? You can see the size of the weight and size of the arrow of the resultant force. Okay, clear?
Yeah.
So I hope this concept is again clear to you, right? So what could be in the next class, you are going to explain me, or you are going to write down the factors on which terminal velocity depends. Clear?
Yeah.
Right? So your assignment is find out the factors on which terminal velocity depends, right?
Yeah.
So are you going to submit this in the next class?
Yeah. Sure.
All right. So you are going to see this graph as well. I think I have discussed this graph in one of the classes, but it is not discussed with you because terminal velocity is not has not started with you. All right. So see this one, this graph. Now, Hamza, can you see this one? And what are you observing here?
Yeah, I can see it.
Yeah. So initially the body has different speed, right? It speeds up, and then finally, when it has a zero gradient, there it reaches to the terminal velocity.
Yeah.
Clear? So
And then when
here,
you open
yeah, when he opens
parachute,
the parachute, yeah, good,
it's
good. Decelerate, okay? It
yeah, until
start
you reach
decelerate,
terminal
and then
velocity.
after that it reaches
Yeah.
to new terminal velocity. Clear? Is this now
Yeah.
clear to you?
Yeah. Yeah.
Okay, I hope there is no confusion in the terminal velocity. Okay.
Yeah.
Okay, Ji. So stay blessed. So I'll be uploading this lecture and it will be shared to you. Okay. Okay, Ji. Allah Hafiz.
Yeah.